Now then guys, welcome to this video where we're going to take a look at a problem that I've chosen from a mathematics admissions test to take a look at in this video. So the point of this video is to work through a problem, an interesting non-routine problem in mathematics, exactly the sort of problems that you're likely to see on a mathematics admissions test or a step paper, for example. And we're going to take a look at the problem solving process. So it's not really the problem and the specific solution to that problem that we're really interested in, but how the solution could be developed, how ideas can be developed into full solutions, full and complete solutions to problems. Okay, so this was a nice little problem. I kind of enjoyed it. We're going back to 2020. The MAT, and it's question number 3. So it's one of the more structured problems from the MAT. So the initial few questions are the multiple choice problems. Doesn't necessarily make them easy, but we're looking at one of the later problems. Okay, so this is not intended to be a model solution video to this particular problem. As with this, my other videos that I've done, and the same applies to this video, this is really getting at the problem solving process, the difficulties that are encountered. So if you've watched any of my other videos, you'll realize that I do there's probably a lot of rambling, because I'm really trying to capture in the moment my thoughts regarding the problem solving process, because it's not necessarily something that can be systematically taught. And that's not to say that the problems I'm solving them live. I'm not. I have solved these problems already. It's just I've written out kind of sketch solutions, so I've got to think through some parts of it again on camera, so that I can try to capture some of that kind of spontaneity. I can only do it to a certain extent, though. The videos are what they are. I don't make any money from these videos. I make them because I want to make them, and I want to help you to prepare for your maths exams, your step exams, your MAT exams, whatever it is that you've got coming up. If, however, you would like some additional help, if you are looking for some extra support, some extra guidance, if you are preparing for these exams, please feel free to get in touch with me. I'd love to have a discussion with you about how I can help you prepare for your exams, and to help you secure a place at the college, sixth form, or university that you really want to go to. I'd love to see you going into your exams with the confidence, knowing that you're gonna absolutely smash them. Okay, so let's get on with the problem. So I've drawn a little sketch on the board. I'm going to include a link in the description to this video so that you can download the past paper that I'm going to be working from. So it's the MAT from 2020, and it's question number 3 that we're looking from. We're presented with this diagram and a bit of information about it. So I'm reading off my computer screen here, which is below the camera, and it goes as follows. Below is a sketch of the curve S with equation y squared minus y. So S has equation y squared minus y equals x cubed minus x. And the curve crosses the x-axis at the origin at A0 and B0 for some real numbers, A, which is less than 0, and B, which is greater than 0. The curve only exists for alpha less than or equal to x is less than or equal to beta, that's between these 2 points here, and for x greater or equal to gamma. Gamma's the x coordinate of this point here. The 3 points with coordinates alpha delta, beta delta, and gamma delta are all on the curve. Okay, so part 1. What are the values of A and B? So, okay, let's make some initial observations. First of all, we've got an implicit function here. It is what it is. You've just got to work with it. That's how it's going to be. So you're going to have to be careful how you're dealing with it, because sometimes I know, particularly if you're just doing normal maths at A level, you don't necessarily get a lot of experience dealing with implicit functions, and they can be something that people kind of get a little bit nervous around, but they're nothing to be nervous about. Okay, so what information do we have at A and B? Well, we know that y is going to be equal to 0. So at A and B, y is equal to 0. So we get 0 is equal to x cubed minus x. And then we've just got a cubic equation, right? So that's going to be x squared minus 1, which is x times x plus 1 times x minus 1. So therefore, x is going to be equal to 0, x is equal to minus 1, or x is equal to plus 1. Well, x equals 0, that corresponds to the origin. X equals minus 1, because we know a is less than 0, must be that a is equal to minus 1, and therefore b must be equal to 1. First part done, nice and easy. Okay. By completing the square or otherwise, find the value of b. So we're going to do the by completing the square using the hint first, and then we can maybe have a look at the otherwise, because there isn't otherwise. It's not necessarily the best way to go about it, but we'll have a look at it anyway. Okay, so it doesn't tell you completing the square on what, and this is what you've got to figure out, right? Even when you're given hints, the hints are not necessarily going to point directly to what it is that you need to do. So when you're doing STEP or MAT, you are really in the driving seat. You've got to decide what needs to be done. Don't expect to be told exactly what you need to do. Okay, you've got to wipe your own backside on your MAT and your STEP. Unlike on the maybe normal A-level maths, where there's a lot more guidance, and sometimes it's less about solving a problem, it's more about just following the instructions that you're given. That's not the case on the MAT. You're really expected to solve the problem. Okay. So, completing the square or otherwise, well, there's only really one thing that we can complete the square on, because we complete the square on quadratic expressions, right? So it's got to be the y squared bit, y squared minus y. So we get y minus a half squared minus a quarter equals x cubed minus x. And what is it that we need to show? By completing the square or otherwise, find the value of delta. Okay, so what we get is y minus a half squared equals x cubed minus x plus a quarter. This implies that they ask the questions in a kind of a strange order here, because the value of delta is going to be a half. Okay, delta equals a half. Why? Because I can see that the line through all of these points that have a y coordinate of delta, that's a line of symmetry. It might not look too symmetric, like a line of symmetry from my diagram, because it's not very well drawn, but if you look, it's a line of symmetry. Okay, and y equals a half. Think about when you complete the square, right? So x minus alpha squared minus whatever. What's the line of symmetry? It's x equals alpha, right? That's the line of symmetry. Well, we haven't completed the square on a quadratic expression involving x here. We've completed the square on a quadratic expression involving y. It's the same principles, right? This, I can still use what's inside the brackets here to tell me what the line of symmetry is. The line of symmetry is, well, in this case, when x minus alpha equals 0. In this case, when y minus a half equals 0. In other words, when y equals a half. The reason I'm saying it's an unusual order that they're asking the questions is because I'm using that bit of information to find what the value of delta is, what the line of symmetry is, and the next question that we're going to be asked is explain why the curve is symmetric about the line y equals delta. which, okay, it's not asking necessarily what is the line of symmetry. It's kind of saying the line of symmetry is y equals delta, but it just seems like an unusual order to me. Maybe it's not unusual. Maybe it's just me. Okay, so there is an or otherwise that we can possibly use here. If you don't necessarily pick up on what the hint is when it says complete the square, which is fine, by the way. If sometimes the hints that they give are not necessarily all that clear, and you just don't see what you need to see. It's happened to me plenty enough times. So what could we do instead? Well, we could try maybe doing some differentiation. So we're going to have to use implicit differentiation here, which at the time of doing MAT, some of you may not have come across implicit differentiation, in which case you wouldn't be able to do this. But nevertheless, if implicit differentiation is something that potentially we could use here. So differentiate this implicitly. We get 2y minus 1 times dy by dx equals 3x squared minus 1. So dy by dx equals 3x squared minus 1 over 2y minus 1. And at these points, alpha, beta, and gamma, the gradient is effectively going to be infinite, right? It's going to be infinity. Or in other words, the denominator of this is going to be equal to, or I could flip this upside down. I could say dx by dy is equal to 2y minus 1 over 3x squared minus 1, and say, and look for when dx by dy is equal to 0. That might be a better way of thinking about it. I don't like infinite gradients. So 2y minus 1 equals 0, y equals a half. So that would tell me when the dx by dy derivative is going to be equal to 0. It will also tell me when dy by dx is effectively infinite, but again, maybe better to think in terms of gradients equal to 0 or derivatives equal to 0. I think I prefer the way completing the square. Mathematicians have a tendency to prefer kind of more elementary techniques being used rather than just blasting straight in with the big guns to solve a problem. Because when you kind of limit yourself to more elementary techniques, you've got to be more creative. As mathematicians, we're not so much interested in just getting the job done by any means necessary. It's about getting the job done in an elegant sort of way. And that means something to a mathematician. So we're not engineers where we just need to crunch a load of numbers, and it doesn't really matter how we get the solution to a particular differential equation or whatever that we're dealing with. To a mathematician, stuff like that matters. Aesthetics is a big thing, okay? And it's something your own tastes will kind of develop as you progress as a mathematician. You will start to figure out for yourself what you think is elegant and what is not. Okay, it's all something that you'll learn to develop. So don't worry about it too much now. If you don't see any problem using implicit differentiation to find the value of delta, use implicit differentiation. Okay, so the next part is explain why the curve is symmetric about the line y equals delta. Okay, so let's suppose x naught is a solution to the equation y naught, half plus y naught squared equals x naught cubed minus x naught plus a quarter. Okay, so here we've set effectively y is equal to a half, just to make it Made a mess of that, haven't I? So x naught is a solution to the equation half plus y naught minus half squared equals x naught cubed minus x naught plus a quarter. So in other words, we've got y naught squared here. Okay, so I've effectively replaced y with a half plus y naught and x with x naught. Okay, then x naught also satisfies the equation half minus y naught minus a half squared equals x naught cubed minus x naught plus a quarter. Okay, because that is also equal to y naught squared. So in this case, we've got what? Y is replaced with half minus y naught, and again, x is replaced with x naught. So, in other words, that x naught will satisfy both of these equations, but if we've got half plus y naught, assume that y naught is a positive number, then we're going to end up with a point, let's say, I don't know, here, x naught and half plus y naught. But then we've got a corresponding point down here, x naught and a half minus y naught. And both of these pairs of coordinates will satisfy this equation. Okay, or this equation, whichever you prefer. Doesn't make any difference. So for each x value, there's going to be typically two corresponding y. I mean, there are going to be some values where there's just a single y value, but typically what we're going to expect is that for each x value, we're going to have two corresponding y values, and they're going to be symmetrical about the line y equals a half. So something like this would be fine to explain. As with any of your solutions to these problems, they don't have to be perfect. Don't be aiming for perfection. You can't anyway in an exam. An exam, you've got all sorts of pressures, time pressures, and things like that. As long as you're getting your ideas down on the page, even if they're imperfect, as long as you're demonstrating to your examiner that you've got good ideas, that you can and you know how to develop them, even if there are a couple of flaws here and there, it's not a big deal, right? So something like this, I'm not saying that this is the perfect way to answer this question. Part 3, explain why the curve is symmetric about the line y equals delta. I'm not saying that this is the perfect way to do it, or this is the only way, or anything like that. But this explains this is my idea. I'm articulating my idea, and that's what is really more important. So don't be getting too obsessed and too hung up on trying to get perfect solutions to problems and things like that. You don't even need to get necessarily complete solutions. As long as you've got some good ideas that you can demonstrate to your examiner, what they're looking for really is this person going to be somebody that we can teach, that is teachable, that could have a successful future in mathematics. Okay, so having good ideas, even if at this stage you're not necessarily able to develop those ideas fully, just showing that you have good ideas is demonstrating that your tutors, your professors and lecturers will have something to work with. Actually learning how to articulate those ideas, how to kind of follow through on those ideas, that's something that will come with time. But the important thing is that you have ideas in the first place. Okay, so question number 4. I'll answer after I've had a bit of coffee. Question number 4, find a cubic equation in X which has roots alpha, beta, gamma, and your expression for the cubic should not involve alpha, beta, or gamma. Justify your answer. Okay, because one way that you could kind of answer this would be to just say x minus alpha, x minus beta, x minus gamma equals 0. Job done, right? Well, okay, not so fast. Our expression can't involve alpha, beta, and gamma. So what you've really got to do is you've got to illustrate, you've got to demonstrate how your understanding of the information that we've kind of derived here and the significance of the alpha, beta, and gamma up here. Okay, so when x equals alpha, beta, or gamma, y is equal to a half. Okay, so when y is equal to a half, what do we get? We get 0 over here. So 0 is equal to alpha cubed minus alpha plus a quarter. 0 equals beta cubed minus beta plus a quarter. Or 0 equals gamma cubed minus gamma plus a quarter. Okay? In other words, alpha, beta, and gamma are all roots of the equation x cubed minus x plus a quarter equals 0. Okay? That's all it is, right? That's all we need. So, again, how you exactly explain this is going to be entirely up to you. As long as you've got the idea, as long as you're showing that you have an idea that's kind of taking you in the right direction, that's the most important thing. Okay, so then by considering the factorization of this cubic, find the value of alpha plus beta plus gamma. Okay, so the factorization of this cubic is going to be x minus alpha, x minus beta, x minus gamma. Okay, so it's either expand all of this out, and what you will find is that you get something like x cubed plus, and then collecting like terms, you'll get, minus, alpha plus beta plus gamma, x squared plus, and so, well, you'll get some more coefficient, but either you do that, and you can see that alpha plus beta plus gamma is going to be equal to 0, because notice that there's no x squared term here. Alpha plus beta plus gamma is equal to 0. Or, if you've done a little bit more work on roots of polynomials and things like that, maybe if you're doing further maths, you'll already know this. And you will already know what the coefficient of x is going to be here, and also what the constant coefficient is going to be. So the other coefficients you'd have alpha beta plus alpha gamma plus beta gamma would be equal to -1, and you'd also have alpha beta gamma is going to be equal to -1/4. You don't need to have done the further maths, by the way, in order to figure these out. You could just consider the expansion of this and understand what it means for two polynomials to be equal. Two polynomials are equal if and only if all of their coefficients are equal. Okay, so that's that bit. And then, okay, the next part is quite, it took a bit of work for me to do, to be honest with you, so we'll take our time with it. Let's C denote the circle which has points alpha delta and beta delta as ends of a diameter. Write down the equation of C and show that C intersects S at two other points and find their common x coordinate in terms of gamma. Okay, so we've got a circle. This is a diameter, so from alpha delta to beta delta, that's going to be a diameter of that circle. And we need to, first of all, we need to find the equation of C. Now, it's a little bit vague about what it expects in terms of the equation of C. In the equation of C, you will still have alphas, betas, and gammas potentially. Now you can get rid of the alphas and the betas and just have it in terms of gamma, and that's what I'm going to do. I'm going to write the circle in terms of gamma. Okay. The reason for that is because if we think about the next part, show that C intersects S at two other points and find their common x coordinate in terms of gamma. This suggests to me that it's probably going to be easier for me if I get rid of the alphas and the betas, if there are any, and potentially there will be some. Okay, so remember, alpha plus beta plus gamma is equal to 0. Alpha beta plus alpha gamma plus beta gamma is equal to -1, and alpha beta gamma is equal to -1/4. Just let me double check that. Yeah, -1. Okay, so we can get rid of this stuff. Don't need that. So to find the equation of a circle, we need its center, we need its radius, right? So center is going to be halfway between alpha delta and beta delta. So the center of C is going to be alpha plus beta over 2 delta. Okay, it's still going to lie on that line y equals delta. Now, notice that alpha plus beta is equal to minus gamma. Okay, and let's have a think about the radius of this circle. So the radius of C is going to be, it's going to be the distance from the center, which has x coordinate. This is all on the same line, by the way. So it's just going to be the distance from the center to either beta delta or alpha delta. So it's going to be beta minus alpha plus beta over 2, which turns out to be beta minus alpha over 2. Okay, so the equation of C is x minus alpha plus beta over 2 squared plus y minus y minus, not delta, yeah, it's a half. Y minus a half squared equals, that's the radius, so it's going to be the radius squared. Okay. Right, so now I want to get rid of these alphas and betas. Okay, that's easy. Alpha plus beta is equal to minus gamma. That means that alpha plus beta over 2, that's going to be minus gamma over 2. So I'll sort that out in a second. What about this then? Beta minus alpha over 2 squared. This is a little bit more difficult. Nevertheless, we can figure it out. Because if we know that alpha plus beta is equal to minus gamma, then we know that alpha beta plus beta times gamma is equal to -1. So therefore alpha beta plus minus gamma squared is equal to -1. So alpha beta equals gamma squared minus 1. And alpha minus beta squared, or beta minus alpha squared. Maybe I should write that actually, so that it matches up with this a bit more closely. Beta minus alpha squared. By the way, it took me a while to figure this out, that I needed to do this, because initially I just left the alphas and the betas in, and I kind of thought that maybe I was missing something, and maybe I should be able to figure out the values of alpha and beta or something. But then I thought, if you know the values of alpha and beta, you're going to know the values of gamma. So then why would they ask for expressions in terms of gamma? So then it kind of led me to believe that maybe it's not possible to find the values of alpha and beta. And I don't think it is possible. So it did take me a while to figure this stuff out. So be prepared to think about stuff. You know, you've got some time in the exam, you've got thinking time, and you need to use it. It's don't expect the solution to a problem to just leap out at you. These are not routine problems. This is not like being asked to differentiate cos x or something like that. where you've done it. It's a routine thing, or to find the equation of such and such a straight line. These are not routine things. You've really got to understand what's going on in a bit more detail with these sorts of problems that you get on the MAT. And if you're looking for just a kind of routine solution, something that you can just slap down on the page to get the job done, that's not how it works. You really do have to have a more thorough understanding. Okay, so beta minus alpha squared plus, now I'm trying to think plus 4 alpha beta is equal to alpha plus beta squared. Okay, so therefore beta minus alpha squared is equal to alpha plus beta squared, which is going to be gamma squared, minus 4 alpha beta, which equals gamma squared minus 4 gamma squared plus 4, which is 4 minus 3 gamma squared. So now I can write the equation of this circle out in terms of gamma. So I get x plus gamma over 2 squared plus y minus a half squared equals beta minus alpha squared is 4 minus 3 gamma squared. So it's going to be 4 minus 3 gamma squared over 2 squared is 4. Okay? So that's the equation of C in terms of gamma. So now, how do we look for points of intersection between two curves? Well, it's like simultaneous equations, right? Notice we've got this y minus a half squared here, which we had, I rubbed it off now, but we had when I completed the square on this, we had y minus a half squared equals x cubed minus x plus a quarter. Well, okay, so I just substitute x cubed minus x plus a quarter in here. I'm going to have to clear some space to do that, but that's what we need to do. So we get x plus gamma over 2 squared plus x cubed minus x plus a quarter equals 4 minus 3 gamma squared over 4. Expand and simplify. So let's do that. X squared plus gamma x plus gamma squared over 4, x cubed minus x plus a quarter equals 1 minus 3/4 gamma squared. So that gives us x cubed. I've got an x squared there, plus x squared. Where are my x terms? There and there. Plus gamma minus 1x plus oh, that's nice. A quarter, gamma squared over 4. So that's going to be gamma squared minus 3/4. Yeah, I remember now. I remember. I've got my notes here, but I was trying to think. Trying to remember what it looked like. Yeah, okay, so we know then that because the circle intersects S at the points alpha and beta, that they are going to be solutions to this. Actually, that's not particularly useful to us right now. We need to find the other solution, right? Now, it does say that the circle intersects the curve S at 2 other places. So we've got these 2 points at 2 other points. It might be tempting to think here that therefore we should have a quartic, right? Because that means that there's going to be 4 points of intersection in total, 4 solutions, right? No, because there's only 3 different x coordinates, 3 x coordinates on offer. Alpha, beta, and we're told the other 2 points have a common x coordinate. And it's that common x coordinate that we need to find in terms of delta. So, in other words, we need to find a solution in terms of gamma to this equation. It's a cubic equation, not a nice thing, right? Okay, so this is where you've got to be maybe a little bit inventive. How are you going to go about this? There's different possible ways that you could go. There is a cubic formula, and it's not going to be of any use to you here, even if you know it. I would almost guarantee that it's not going to be any use to you, but you don't need it. So the way that I found the other solution to this was basically trial and error. Now, typically you wouldn't try to solve an equation relying on trial and error, but sometimes it works. And if you find a solution to an equation just by chance, then you found the solution. Okay, it's as simple as that. You don't have to arrive at a solution in a systematic way. And I wouldn't say that it was just pure chance that led me to a solution. It was making careful observations. Okay, so the first thing that I tried, and I knew it really wasn't going to work, but I kind of tried it anyway. I just tried x equals gamma, just to see what happens. So in that case, you get gamma cubed plus gamma squared plus, you'll get gamma squared minus gamma plus gamma squared minus 3/4 equals 0. Not equals 0. But this doesn't work, okay? This is not forced to be equal to 0. So that's not, as far as I'm concerned, a solution. But it can motivate you to other possibility, to try out other possibilities. The thing that I noticed here was this minus 3/4. Okay? Because if you think about the curve S, what we had y minus a half squared equals x cubed minus x plus a quarter. Okay? And I know that gamma is a solution to this equation here. Okay? Gamma is a root of this equation. By the way, this is why we've been asked all of this stuff. To find an equation, a cubic equation, where alpha, beta, and gamma are all solutions, we need to kind of use that, okay? So we've got the minus 3/4 here, and we've got the 1/4 here. So my guess was that we were gonna be dealing with whole numbers in some way. That probably 1 was going to be involved, because 1 minus 3/4 is equal to a quarter. Stating the obvious, but it's these simple kinds of observations that can make something click. Okay, so I was thinking either x equals gamma plus 1 or x equals gamma minus 1 might possibly work here. And just as it happens, I tried x equals gamma minus 1 for the simple reason that I was thinking, well, if I've got gamma minus 1 here, that's going to give me gamma minus 1 all squared, which is going to give me the plus 1. And plus 1 minus 3/4 is equal to a quarter. Okay, I've not taken this into consideration yet, but let's give it a try. And it turns out that x equals gamma minus 1 does actually work in here. So let's have a look. So if x equals gamma minus 1, what do we get? We get gamma minus 1 cubed plus gamma minus 1 squared plus gamma minus 1 squared again plus gamma squared minus 3/4. This is going to be gamma cubed. Binomial theorem might be quite useful here for you. Minus 1 plus gamma squared minus 2 gamma plus 1 plus gamma squared minus 2 gamma plus 1 plus gamma squared minus 3/4, which is gamma cubed. We've got gamma squared, gamma squared, gamma squared, gamma squared. Oh, they all cancel. That's good. Excellent. 3 gamma minus 2 gamma minus 2 gamma minus gamma. Minus 1 plus 1, cancel. 1 minus 3/4 plus a quarter. And that must be equal to 0, because we know, again, gamma is a solution to the equation x cubed minus x plus a quarter equals 0. So gamma cubed minus gamma plus a quarter equals 0. So the other solution, the common x-coordinate of the other 2 points of intersection is going to be x equals gamma minus 1. You are not asked to find the corresponding y-coordinates. You don't need to find them. You can do if you want to, or you can try to find them if you want to, but you don't need to. Okay, this is all we're asked to do. So the other points of intersection of the circle with the curve S have, both of those points have an x-coordinate equal to gamma minus 1. So it's a little bit of good luck in some cases, but really making careful observations. And this is what you've got to do sometimes to find solutions to problems. You've just got to look very carefully at what you've got there and try to see some sort of pattern that you can take advantage of. The pattern might be very abstract in some cases. It might be something that it's difficult for you to put into words, but you know it's there. And if that's the case, so be it. Okay, I don't have to justify in my solution how I came up with this. X equals gamma minus 1. I can try to if I want to. And if somebody were to ask me, how did you come up with that? I can try to articulate it, how I came up with that. But I don't have to. I could just say, don't know, I just guessed it. That's not the case in this particular bit. If I did just happen to guess x equals gamma minus 1 and it happened to work, that's it. It's not a very reliable strategy, generally speaking, but it does work sometimes. Okay, so hopefully I've explained everything clearly in this video, although I doubt very much that I have. If there is anything that you're not sure about, please leave a comment in the comments section. Any questions that you've got, I'll be glad to get back to you. Please hit the subscribe button for this channel, because I'm really trying to reach out to a wider audience. I'm really trying to reach out to those people who need help with their preparations for STEP and MAT exams in particular. If they're applying to university to do mathematics, I really want to get to those people, to help them. So if you do know anybody that you think would benefit from these videos, please let them know about this channel. Please hit the subscribe button, show your support. I'm starting to lose my voice a little bit now. Please hit the subscribe button to show your support, and please hit the like button. That brings us to the end of this particular problem, and it brings us to the end of this video. Thanks for watching, guys.